Guys, this video will be a video over the Pythagorean theorem, and we're just going to do an introduction to it on who invented it and how it works based on the formula, and we'll go over an example of why it works. So let's talk about who invented it first of all. His name is Pythagoras. Okay, I'll write it out here for you. Excuse the handwriting with my stylus. So we have Pythagoras, that's who invented it. You'll notice that he named it after himself, or the name is after him. So Pythagorean, if you just take off the EAN and put AS, that's what it is. So Pythagoras invented the Pythagorean theorem. He was a Greek mathematician and philosopher. So that's the person who invented it. And we are going to just go over the basics of it. Let's start with a triangle. And this triangle is going to have one angle that's 90 degrees. And you might remember that a 90-degree angle is called a right angle. Okay, so we have a 90-degree angle here. That's called a right angle. So we have a triangle that has a 90-degree angle in it. That means that you can call this triangle a right triangle. So when a triangle has a 90-degree angle in it, you can call it a right triangle. So this is a right triangle. And we're going to go over how the sides correspond to each other. So let's go over one other detail before we actually begin. Opposite of this right angle, we're going to call this right here that I will color over in green, we're going to call that the hypotenuse. There we go. Okay, so the hypotenuse. This is the hypotenuse. So opposite of the 90-degree angle. So you just have to look to the opposite side of the 90-degree angle, and it's the hypotenuse. And the hypotenuse is the longest side. Okay, this is the longest side. Just so you know, when you do a right triangle, you have the right angle here. Opposite of that, you have the hypotenuse, and that's the longest side. So let's erase some of this stuff. Let's go back to how these sides actually correspond to each other. So let's call this side A, let's call this side B, and this side C. He made a theorem that said, okay, we know this length. Let's call this length A. If I made a square out of it, and I made a square out of this, and I made a square out of this. So we have A, and if I make a square that has all length A's, like whatever this number is, just make a square out of it. So if it's a 3, make it a 3, 3, 3. So make a square with all of the same lengths here, because it is a square. It has to have all sides that match. And make a square here that matches in all these lengths, and make a square that matches this length every time. And that's what I did. So I'm going to go ahead and label them. So we have a square that started with an A, and all these other sides are A's as well. We had it started with a B, and all these other sides are B's as well. And we started with a C, and all these other sides are C's as well. The area of this first triangle, or this first square, I mean, is A squared. And the area of this square is B squared. And the area of this squared is C squared. So I said A squared because A times A is A squared, B times B is B squared, and C times C is C squared. And he said that the way that these things are going to correspond is that A squared plus B squared will always equal C squared. So he said that this square plus this square will make it equal to that square. And let's kind of do an actual problem to try that out so you can see it for yourself. Let's say that this is a 3, this is a 4, and this is a 5. And you're going to make a square that has 3's on the side. Make a square that has 4s on the side. Excuse my artistic ability, but make a square that has 5s on the side. So this square, 3 times 3 is obviously 9 for its area. This square, excuse me, make this a little bit better of a square, kind of looks like a rectangle. We have 4 times 4, that's 16. And then this square, we have 5 times 5, and that's 25. Okay, so we would have a square here with 9, a square here with 16, and a square here with 25. And if you try that out, the area plus the area equals the last area. So the area of A plus the area of B makes the area of C. And you're going to get that every single time. So if you take this number and you square it, meaning you multiply by the same number, again, remember that 3 squared is the same thing as 3 times 3. So what you did right here to get 9 was you did 3 times 3, which is 3 squared. So to get this 9, you did 3 squared. So this 9 was essentially 3 squared. And the way you got 16 was you did 4 times 4, which was 4 squared. And the way you got 25 was you did 5 squared. And you're going to have this every single time. You're going to see that a squared plus b squared equals c squared. So that's just an introduction to the Pythagorean theorem. Pythagoras is who invented it, a Greek mathematician and philosopher. And he just said that, okay, let's have a right triangle. It's called a right triangle because there's a right angle in it. Opposite that right angle, we'll call it the hypotenuse. And if we built squares on the outside, the areas will relate in the fact that this area plus this area will equal that area. So a squared plus b squared will equal c squared.